All right, today we're going to be looking at some ion notes. So a question to think about is, what are ions and how do we determine their charge? So these are going to be different than our isotopes we already looked at during nuclear chemistry. So in the lab review, you're going to put the elements in order of reactivity. Copper, magnesium, and tin. Those were ones that were tested metals. And then answer the question, why do you think certain elements are more reactive? What makes them more reactive? In a complete sentence. On our next page, write the electron configuration notation for neon. So that is where you get the 1s2, 2s2, based on the energy levels, orbital, and the number of electrons. Then write the configuration for argon. Take note that both of these, neon and argon, are noble gases. And think about why are they not reactive? So, for example, neon has 10 electrons. And argon has 18. It's just one period underneath neon. So looking at these, let's look at their outermost energy shell. So look at energy level 2 for neon, energy level 3, that's our last ring where the electrons are. Look at how many electrons are in both of these. What is in common with the number of electrons? Electrons are going to be the exponents on top. So what do they have in common? The outermost energy level in a noble gas has the configuration of, it's going to have 8 electrons. And most of them are going to end with P6. So they're going to have something S2 and then P6 until you get to krypton. Then those will have 3d10, but they'll typically end with P6. Sorry. P6. Helium is the exception. Its electrons are in the first energy level, which only give it an s orbital, so it won't have P6. It'll be 1s2. This configuration is also known as octet. And it's very stable because it has a full outer shell. Other elements on the periodic table want to have a stable configuration like this octet. The octet rule is atoms will gain or lose valence electrons to acquire a stable electron configuration of a noble gas, usually 8 valence electrons. Noble gas, or known as octet. So we use the atom's number of valence electrons to predict what this will do to become stable. So if it has less than 4 valence, it's going to lose electrons. If it has more, it's going to gain electrons. So atoms that gain or lose do not have an equal number of protons and electrons. Unequal protons and electrons result in a positive or negative charge. And ions are atoms that have lost or gained electrons and now have a charge. So atoms will gain or lose the blank possible number of valence electrons to achieve an octet. So atoms will gain or lose the least possible number of valence electrons to achieve octet. It's easier to gain 3 than it is to lose 5. This one's a practice here. So sodium has 1 valence electron. It's in group 1. Sodium is Na. Which is easier, losing 1 or gaining 7? Highlight the correct choice. lose 1, or gain 7. So this one, I think it's easier to lose 1. That's a smaller number. Compare the number of protons and electrons. So here, in a stable, you have, or neutral, you have 11 and 11. In an ion, you have 11 protons and 10 electrons. So the sodium ion has a +1 charge, and its symbol is written as, it would be Na, and then you do control period +1. Usually you don't write the 1, you usually just put plus. You only put the number if it's like greater than 1, but you can put Na +1. The ion's electron configuration looks like. So if sodium is 1s2, 2s2, 2p6, and then 3s1, if you get rid of that outer electron, the ion's configuration, so if you get rid of 1, it's going to now have 10 electrons, would look like neon's electron configuration. So that would be your ion configuration. Again, if you have the stable or neutral atom, it would end in 3s1. Ion is going to end in 2p6. You'll continue the same here for magnesium. Do some practice. What are the right answers? The number of valence for aluminum. Aluminum is in group 13. It has 3 valence electrons. Would it, so you'd highlight 3 here. And then answer the following questions. Continue with slide 10. Do the same thing as we did for sodium. 11, just more practice. You're just going to highlight the correct answer. The group number for sulfur is, so sulfur is typically group 6 when we look for valence. So it's going to be 16. So you would highlight 16. Answer A through D. Ionic charge. So ions of metals have a positive charge. These are typically called cations. Cation. Nonmetals have a negative charge. They're usually called an anion. Anion like antagonist. Cation like a cat that's positive. And noble gases do not form ions because they already have a complete outer shell. Their last energy level has 8 valence electrons, so they do not form ions. And the last page here, it gives you just some trends of charges. The middle can switch between certain charges. Sometimes they have 2 or 4 or 3. Group 1, since they have 1 valence, they're going to lose that valence and become +1. Group 2 has 2 valence. It is easier to lose 2 than it is to gain 6. So they will lose electrons having a +2 charge. This means they have 2 more protons than electrons. Group 3 over here, where aluminum is at, it is easier to lose 3 than it is to gain 5 electrons to have 8, because these have 3 valence already. So if it loses 3 electrons, it has 3 more protons. So for example, aluminum, if it's +3, would have 13 protons and 10 electrons, because it has 3 more protons than electrons. Group 4 is in the middle. Those ones typically share electrons, not necessarily give away or gain. Then we get to group 5. Nitrogen has 5 valence electrons. It is easier to gain 3 electrons than it is to lose 5. So this one would have 7 protons, and if it gains 3 electrons, it would have 10 electrons for nitrogen. Then we have oxygen is group 6, so it has 6 valence electrons, so it's easier for it to gain 2 than it is to lose 6. Lastly, we have our halogens. They're group 7. It is easier for them to gain 1 electron to make octet than it is to lose 7. So these ones would form a -1 charge. For instance, chlorine would have 17 protons, that's the atomic number, and since it's gaining an electron, it would have 18 electrons and 17 protons. That's where the -1 comes into play. And those are our ion student notes. Once you guys complete all of the slides, make sure to hit submit.